So on these first few, what was our first step in solving, guys? Distributing. Very good. Okay. So I'm going to distribute that -2 into my parentheses. So I have 8y. -2 times y would be -2y. Good. And -2 times -3 is +6. Good. Equals 18. All right. So after you distributed, what do you guys get next? Right. We can combine those like terms. They're on the same side. So what is 8y minus 2y? 6y. Right? Added what? They're on the same side, right? So we just put them together. That's what we do if we move it across to a different side. All right, so speaking of moving things to different sides, what are we going to want to move now? Subtract the 6. Good. All right, and what is 18 minus 6? Good. So last step would be to divide. Very good. So what is y? Good. Good job. Okay. On number 2, what was our first step? Distribute again. Okay. So what's 2 times t? And 2 times 2. And then we still have minus 3t equals -1. All right. Then what do we do? All right. Put those two like terms together. So what is 2t minus 3t? -1t. Good. And then we still have that plus 4 equals -1, right? Okay, then what should we do? Subtract what? Good. So -t is equal to, good. And then our last step is to divide, right? What am I dividing by? -1. Very good. So I end up with t equals +5, right? 2 negatives make a positive. Very good. Okay. All right. So in our lesson for today, it's actually not going to be too terribly much math, which I know we all want to do, right? It's going to be more about reading the problem and identifying our independent and dependent variables. Okay. So they define what those things are for us here. All right, so our independent variable is our input on the x-axis. So my independent is my x's. My dependent is the output, or is on the y-axis, so this would be all of my y's. Okay? It says that the value of the dependent variable, just like its name would suggest, is going to depend on the value of the independent variable. In other words, the dependent variable is a function of the independent variable, which is exactly what we've been talking about, right? The input was our x's, you plug it into the rule, and then your output was always your y's, right? So same thing here. So on number 1 here, they give us this real world scenario, and we're going to pick which one we think represents the independent, or the x's, and which one represents the dependent, or the y's. So it says, on average, Jay can ride his bike 12 miles in 1 hour. The function m equals 12h represents the number of miles m he can ride in h hours. Okay, so these are the two things that we're considering, right? They broke it down for us. M for miles, h for hours. We just need to decide which one of these depends on the other. So Does how long you can ride your bike depend on how many hours you have? Or would the hours depend on how many miles you go? What do we think? The first or the second one? The first, right? Time doesn't stop or go for anybody, right? Time is what it is. So your time is typically always, if it's in the scenario, going to be your independent, okay? So our input or our independent is H, the hours. All right, output. That means my output must be the other, which was the M, miles. All right? Okay, it says which quantity in this relationship is the dependent quantity? Well, is input or output the the dependent? So look up above at those definitions. Which one says output? The Y, right? So is that one the dependent or the independent? The dependent, right. So when it says which one's the dependent, it's our output or our Y, the miles. Which means the independent must be good. So input means the same thing as independent, right? I and I, all right? And then output is the same as dependent. Okay, so then they ask, which one of the following statements is true? The number of hours depends on miles, or miles depends on hours? Which one is it? You guys already answered this for me. The number of miles depends on the hours, is that what you said? Yes, very good. Good. Okay. Then the last thing they want us to do is come up with the domain and range for this scenario. So it says, after work, Jay only has 4 hours to ride his bike before it gets dark. What domain and range are reasonable for this situation? Okay, so if he has 4 hours to ride, that's the most he can possibly ride for, right? What's the least he can ride for? Just think about it. If you were him, what's the least you could ride your bike when you get home? Nothing, right? You could just not ride at all, right? So you could ride for 0 hours at the least, but you could ride all the way up to 4 hours, right? Okay, and we said hours is the independent value, which is like my domain or my x's, right? Okay, so my domain is the hours, which you guys just told me the least they could possibly be was 0. Oops, I just moved the whole thing, didn't I? Is 0, but the most it could be is 4. So I put my smallest, which was the 0, on the far end, and my biggest, which is the 4, on the other end, and my domain is the hours, and we said we know domain is our x values, right? So I'm going to put my x in the middle with my inequalities. Could he actually ride 0? Yeah, so I'm going to put an equal to sign because we could include the 0. Can he ride the whole 4 hours? Yeah, so I'm going to put the equal to because he could go the entire 4, right? He doesn't have to stop before that. Okay, now we need to find the range, which is going to be our miles, right? Or our y's. And for my miles, whenever we're talking how many miles we can go, they said he could go how many in an hour? 12. Okay, so we said the most he would ride would be for 4 hours, right? So that would be 12 times 4. What is 12 times 4? Yes, 48, And we said the least he could possibly ride for was how long? 0. So if m of 0, then I would have 12 times 0, which is 0. So what's my smallest answer that we got? 0. And what's the biggest answer that we got? Good. And then I just go put my y in the middle and my inequalities on either side. Again, he could actually ride 0 miles, so I want to put the equal to, and he could actually ride the whole 48, so I'm going to put the equal to there as well. All right? Okay, once you have that, if you will flip it over onto the back, it says Paul pays a $27 rental fee for a sailboat and $15 for each hour that he uses the sailboat. Let C represent the total cost of renting the sailboat for H hours. And we're going to write the equation. Okay, so the two variables they told us that we're using this time is C for cost, right? And H for hours. Okay, so normally when we write an equation, we write it in y equals mx plus b form, right? So the y usually goes first, and the x is somewhere in the equation, right? And in this scenario, our two variables are cost and hours. Well, hours is time, right? And we said time is usually going to be our what? Our independent, which is which letter? X or Y? Very good. So that would make this my x, and that would make this like my y, right? So if I normally put y equals, what letter is representing y? C. So I'm going to have C equals. All right. And they said that he's going to get charged how much? $27 rental fee. And what does that word and mean I need? Plus 15 per hour. How do I write that? Very good. Okay. Then it says to write it in function notation. So same equation, but in function notation. Remember, function notation is when we put it as f of x, right? Okay. So what letter is x again? H. So that would mean inside the parenthesis I should have an H, right? Which means the letter in front has to be the other letter, which is the C, right? But it still equals the same rule, right? F of x still always equals mx plus b, right? So what did we say our rule was? 27 plus 15h. All right. Okay, so again, which one of these quantities is the dependent? Yes, C, right? And C is representing the cost. And my independent is my hours. Very good. Okay. So then they ask us a question, a multiple choice question about what the domain and range for this scenario would be. So it says Paul has a budget of $200 to spend on renting the sailboat. What domain and range are reasonable for the situation? So remember, our domain is our x, right? And we said that our x is the hours. So for a domain, I'm only talking hours that they could spend on this boat. Okay. We know how much money that he could potentially spend, right? They said that he could spend all the way up to how much? 200. What's the least he could spend? 0, right? So we know for a fact the most he could spend is 200 and the least he could spend is 0. And this is cost we're talking, right? So we already know this much, which is going to eliminate which answer choices. So which one doesn't have 0 is less than or equal to C is less than or equal to 200. C and D, very good. So we can mark, ooh, I just moved the whole thing again. So we can go ahead and mark out C and D, right? Now we just need to figure out the hours behind spending that much money, right? Well, if he spends $0, that means they took it out for how many hours? 0 hours. So we know that the other end has to be 0. We just need to figure out how many hours he can go with $200, right? Okay, so we came up with an equation already. If the cost is 0, we already know what that means. But if the cost is 200, I'm going to go plug that in right there and see how many hours that would give me. Okay, so I'm going to have, instead of C, we're going to plug in 200, because that's what we know the cost is equal to 27 plus 15H. All right, so what would we do first to solve here? Good. And what is 200 minus 27? What's 200 minus 27? 173, good. All right. Then what should we do? Divide. All right, and what is 173 divided by 15? 11.5. Okay, so H is 11.5. All right, so that is not what either one of these say, right? One of them says 11, one of them says 12. But he only has $200, right? So can he rent it for that 12th hour? No, he doesn't have enough money. So the most he could take it out for would be for how many hours? 11. So that would mean it's answer choice B. Good job. All right. Okay. Got another scenario here. This one says, Katie's mom gave her $15 to send flowers to her friend for her birthday. To determine the total cost of the flowers T, the equation T equals 0.6 L plus 750 can be used, where L represents the number of lilies used in the arrangement. Which quantity in this relationship is the dependent quantity? Okay, so is dependent the X or the Y usually? The Y, okay, because it's going to depend on our independent X. Okay, so in the equation, which letter was where the Y usually goes in the equation? Which letter is where the Y goes in the equation? Which letter is in the place of Y in that equation that they gave us? The T, right? Normally it's Y equals, and they put T equals. So if my dependent is my Y's, and T is where Y is, T must be the same thing as Y, right? And what did they say T represented? The cost of the flowers. Very good. All right, so this is T, total cost of flowers. Very good. Okay, and we know our independent is usually our X, and what letter is where X is? The L, and what is the L representing? They told us in the question. Where L represents the number of lilies. All right. So now we know what's our independent, what's our dependent. Now they ask which one of these is true. The value of L is constant to the relationship T. The value of T is constant to the relationship L. Well, neither one of those said anything about being constants, right? They said they're independent and dependent. We can go ahead and mark those two out. C says value L is dependent on T. D says T is dependent on L. So which one is dependent on which? T on L, right? All right. Then they ask, what is the maximum value for domain? Domain is my X's or my Y's? X's, okay. So now they're asking how many lilies, basically, right? Okay, well, what's the most lilies that she could buy? We don't know, right? But what's the least amount of lilies she could buy? 0. Okay, so we know it's going to start out with 0 is less than or equal to L is less than or equal to something, right? Our job is to figure out how much can she buy with the amount of money that she was given. So how much money does she have? 15, all right? So that means I'm going to take that 15 and plug it in for my total cost and see what do I get for my lilies. So I should have 15 is equal to 0.60 L plus 750. All right, so what do I do first? Subtract. What is 15 minus 750? 750. So I have 750 equals 0.60 L. Then what do I do? And what do we get when we divide those? Good. Okay. So 12.5 is the number of lilies she can buy. Can you buy half of a lily? No. So really, how many can she buy? 12. There we go. All right, last question. It says if y is a function of x in the equation y equals 6x minus 4, which of the following statements is true? Okay, so first of all, is x or y the independent? You need to, you got it written on the front page if you need to flip back over and look. The independent is the, which letter? X or y? The x. Yeah, independent is the x, okay? So, when I'm reading these, I need it to say independent is x, or we know it's wrong, right? So, A says independent variable x, so that's good. B says independent variable y, so that's not right. I can mark that one out. C says the dependent variable is x. Well, that's not true, right? We just said that x was the independent. And D says dependent variable y. Okay, so that could be true. So we've narrowed it down to 2 answer choices. Okay, they both say that x is the independent, either at the beginning or the end of their sentence. Says that the independent variable x is 4 less than 6 times the dependent variable y, or the dependent variable y is 4 less than 6 times the independent variable x. Okay, so here's the equation, right? Y equals 6x minus 4. When we practiced writing our equations earlier in the year, when we saw that, when we put in the equal sign, what word did we see in the problem to let us know we should put an equal sign? What word lets us know that it equals? Is, right. So I need something that says y is, right? So which one of these says that? This one says x is. D says y is. So which one is it? Y is. So y is 4 less, which is what this minus 4 means, 6 times the x, right?